Welcome back to the channel. If you're new here, please subscribe, like and share our videos. Today I'm going to show you how I designed a wall-mounted floating wireless charging phone holder. The phone holder can be used besides the bed for night charging and to hold your phone generally. I did the design work in Blender and 3D printed it on an Ender 3. I'll take you step by step through the process of design and 3D printing. Stay tuned to the end, like, share the video, and I hope you'll be able to learn something. We first take the measurements of the components that we're going to use, the charging head and the USB cable that is going to go through the charger. Note down these measurements. We also need to refer and note down the dimensions of the phone that we are going to use with the charger. In our case, we'll be using a 7-inch phone. Now we open Blender and begin the process of modeling. First and foremost, we need to adjust the dimensions and the scaling units. Since we'll be using millimeters for our workings, we go and modify these settings to millimeters, and then we add a mesh cube. This cube is going to be used to simulate the phone that we're going to use. This is how I usually do it. Each cube is usually 2 millimeters by 2 millimeters or 2 units by 2 units. In our case, it will be 2 millimeters by 2 millimeters. Going back to our measurements, we will calculate the factor that we need to multiply with to get the dimensions of the model phone that we're going to make. Now, in order to scale up the cube, we will take the factors that we noted down and we will multiply it by the dimensions. For example, if we had a factor of 3 for height, we are going to multiply 2 by 3 and we'll get the height up to 6 millimeters. You do the same for the height, the width, and the length. Once that is done, we will disable the cube. We will make it invisible and we will import now a mesh cylinder. This one will be used to make a model of the charging plate. The charging plate, remember, is cylindrical in shape, so we need to get the shape and the dimensions in order to do the Boolean functions that are available to us in Blender. We do the same. We multiply the height, the length, and the diameter by the factors, the scale factors that we had calculated before. As you can see, we have got the model right. Now we go to the next step. We will make both the cube and the cylinder visible, and now we will align them the way we would like to align them
when we are using the charging pad. To move objects, you press G and the dimension to which you want to move it, if it's in the Y, Z or X axis. So in our case, we'll move the cube, we'll move the cylinder down so that it mimics the appearance of a phone on a wireless charging pad. This is how it looks. Once we get that done, we move on to the next step where we import the mesh cube, and this is what we are going to use now to get the actual pad. Using the Boolean functions of subtraction, we'll be able to carve out the shape of the phone and the shape of the charging pad
from the shape of the bigger cube that we are going to create now.
We'll follow the same procedure. After importing the mesh cube, we will multiply it by a factor if we have specific dimensions for the charging stand. If we don't have exact dimensions, then we will just scale it up and see where it will fit best. For this, we scale up the y-axis, the x-axis, and then the z-axis. If you look at it, it has completely covered the charging pad and partially covered the phone model. This is exactly how we would like our platform or charging holder to look like.
2,000 years later.
So using Boolean functions and several other functions in Blender, we are able to come up with this design and shape. Now from here we can be able now to print it. First and foremost, we need to highlight the item that we want to print, because you have multiple items in this project. From there you copy it and then open another instance of Blender. Delete everything and then paste the object that you copied from the other instance of Blender. Here now we can see we only have one object to work with, and from here we can export it as an STL to the desktop or to an external drive. Once we have exported the STL, we go to the folder where we exported the STL and open it using Cura app. Once you import it in Cura, you'll see that initially it will not be able to fit, so you need to rotate it to 90 degrees so that we can be able to fit on the print bed. It is always advisable to look at your model all around so that you can be able to see if there are any errors before you slice it. After slicing, have another look at the model, how it will look during print and after. And if you're satisfied with the look, you can now save it to an external hard drive or an SD card ready to print on the 3D printer. Eject your external drive and hook it up to your printer and proceed to do the 3D printing. As you can see, I'll be using an Ender 3 to do our prints. Take the SD card out of the card reader and insert it on the machine before you power it up. Make sure that the 3D printer is placed on a level surface before you start any printing. The other thing that you need to do before you proceed with printing is to check if your bed is level. And you do this by first of all homing the machine.
Bothers my wife, but it's not his fault. My wife's memory isn't what it used to be. That's why she does weird things. If she told me, I'd buy her a nice bangle. Now I'll make her a wooden one myself. It's hard to design on wood, but I'll do it. No one supports me. Will you support me? Please like, subscribe, and comment with a red heart. After hours of work, my wife's bangle is ready. Let's show her. Here's your bangle. Give me your hand. I'll put it on.
This is beautiful. Thanks, dear husband. I'll make a nice bangle from this watermelon. Wow, my bangle is ready.
Crazy old lady, taking I ate your watermelon?
Why did you eat my watermelon?
Are you really crazy? Who makes bagels from watermelon?
After homing the machine, turn it off and disable the steppers, or disable the steppers if you don't want to turn it off, but it's always advisable to turn it off and disconnect it from power. Then, using a thin sheet of paper, place the paper on the bed and, without interfering with the Z-axis, try to move it around between the nozzle and the bed. If you find a lot of resistance, please adjust the bed to go lower so that the distance between the nozzle and the bed is increased. If you find that there is too much play, then raise the bed a little so that you decrease the distance between the nozzle and the heat bed. You can start by doing this around the four corners of the heat bed. This will help you level out the bed so that you will not encounter any problems when you start doing your prints. Remember, this is a compulsory step that has to be repeated severally in order to get the level right. If the level is attained correctly, you'll have avoided issues of nozzle clogging and bed adhesion.
Okay.
Once done, you can now go and load on your filament. As you can see, I have a collection of filaments, but for this project, since we will want to finally paint it black, we will choose a filament that has a plain color, and the one that I have lying around is in blue. Thread the filament through the feeder and the Bowden tube. Until it gets close to the hot end. From here you can hit the hot end first. After that you can thread the filament through until it comes out through the hot end. After that you select the print file that you want to print, and then you start your print. Additive manufacturing, that is 3D printing, is a slow process, and if you're printing in fine settings, it means it will take longer because the nozzle will be dispensing less of the printing material over time. This will enable your print to come out smoother, but will also take a longer time. It also depends on the nozzle that you're using. If you're using a 0.4 millimeter nozzle or less, the print time will be significantly longer than if you're using a larger size nozzle, because the larger size nozzle will be dispensing the plastic at a higher rate than the smaller nozzle, and thus it will be faster. Larger nozzles are usually ideal for doing large prints whereby the details are not very critical. But if you're printing something like a figurine, then you would need to use a smaller nozzle and use more printing time. Just a quick tip for beginners. So when you find time and you have your filaments and they have been out in the open air, you need to place them in an oven and dry them out. When storing your filament, you should always keep the filament in a dry box, and if possible, find some desiccant and put it inside the box as well. PLA filament is hygroscopic and does absorb moisture when left in the open air. Finally, our print is finished. We take it out from the hotbed and we start our post-production. Post-processing is where we remove as much of the unwanted material as possible, and we try to refine our model to a more presentable look. We start by cutting off all the excess hair-like structures, the threadings, and everything else that we do not need. Here I ran into the first problem, whereby the QI charging head or the charging pad could not fit into the hole that was designed to fit it, and therefore I only had one option: to sand it down. To avoid this issue, you can scale up your model to 0.02 or simply increase the size of the QI charging head model. I believe this might have been due to incorrect settings on my Ender 3 or simply a calibration issue on the same.
2,000 years later.
Well, as you can see, I finally managed to get it to slide into the slot, but to avoid this, you better just scale up the model, or when you're creating the hole, make it a little bit bigger than what I did. Well, as you shall soon discover, I quickly ran into another problem. The port that I had designed for the USB cable head was in fact narrower than the actual USB cable that I had. So in essence, the cable could not go through the slot unless it was modified in a way. This is the kind of sleeve that I had designed for, while this is the sleeve that I had. To print the wall bracket, we'll go through the same process that we used to print the main phone holder, whereby we'll go back to Blender and then we will copy the object, which is the wall bracket, and then we will open another instance of Blender. We will then delete all objects, then paste the object that we want to print, and then export it as an STL. Then open it via Cura Ultimaker. The wall bracket can be printed standing upright, or it can be printed lying down to increase the strength, as the print lines will be going across as opposed to stacking over each other. So if we print it flat on the bed like this, it means that the strength will be enhanced. The infill density is at 100% for this one, and the settings for the 3D printer should be in fine settings. We head over to the 3D printer, select the G code, and we start our print. The beauty about this design of a wall bracket or a phone holder is that you can print many wall brackets and then mount them in different locations on the right or the left side of the bed, and you can simply just move the holder to whichever location you would like without having to re-drill the holes again for the new bracket. The bracket does not consume a lot of filament. To enhance the appearance of the model, I decided to paint it black, glossy black, with black spray paint from Sparkle. To do this, you need to have covered your nose, mouth, and if you have goggles, you should cover your eyes as well for your safety. This is aerosol paint, and therefore when inhaled might be toxic to you in the long run. Once you're done with the first layer, leave it to dry, and then you can do a second layer and a third layer depending on how you want the finish to come out. For a super glossy finish, you have to do at least 3 layers of the black paint. This process can be skipped if you have black filament at hand. This is the final product after paint has dried out, and I think it has come out quite well. So now we test it and then we mount it on the wall. The wall bracket turned out to be a very tight fit, so we had to sand it a bit in order to make it easier for it to go through the attachments that it was supposed to go in through.